after isomorphism, how many additive abelian groups G of order 16 have the property that 4x equals to 0 for each x? So still run, you need to remember that if G is finite and G is abelian, then G is a direct sum of Sigley group. So for G order 16, it's 2 to the 4th. So we can count separate it into different kind of abelian group. So the first one is the first one is Z16. The second one is Z8, direct sum Z2, Z4, Z4 is also 16, right? So also Z4, Z2, and Z2. So we have 5 of them, but only one. So we need to choose which one 4x is 0. So definitely this is not right, because this 16 means the Sigley group of 16, order 16. So 1 times 4 is 4, mod 16. So it's definitely not 0. And this one contains, so the element inside this is, the first one is some element module mod 8. The second one is some element mod 2. So if I times 4, then it becomes 4a, 4b. And 4b is 0 in the mod 2. But 4a can be non-zero in the mod 8. Suppose a is 1, then this is 4. 4 is not 0 in mod 8. So this is now okay. But this one is okay, because we have a and b, and this times is 4a, 4b. And the 4a and 4b is 0 in the mod 4. So this is okay. Also for this one, the element inside is a, b, c. And a is in mod 4, b is in mod 2, c is in mod 2. So when you times 4, you get 4a, which is 0 in mod 4. And the 4b is 0 in mod 2. 4c is 0 in mod 2. So these 3 are okay. So we have 3 of them. The answer is D. So basically, this is the fact that in the common fact that in the abstract algebra. So if you don't know this proof, then I will leave the comment below. I will leave the link below that you can go to check it.